Good day. Today we'll be discussing rectilinear acceleration. Now, first of all, what does the term rectilinear acceleration means? Rectilinear acceleration means the rate of increase of velocity along a straight line path in a unit time. So in simple terms, it is acceleration along a straight path in a unit time. Now, when a velocity of a body changes, it's either due to acceleration or deceleration. Now, acceleration I'm going to denote my acceleration by A, is the increasing rate of velocity with respect to time. So I'm going to express this as change in V over change in T, whereby change in velocity is positive. So I'm going to put this in brackets. Acceleration is positive. On the other hand, deceleration is just simply negative. Now, it's a decreasing rate of change of velocity with time. So it's still changing velocity over change in time, only that it's a negative value. Now look at it this way. Let's say a boy from point A to point B. At point A, the boy's velocity is 5 meters per second, and at point B, it's 10 meters per second, and the time interval between this, which is represented by change in T, is 1 second. Now, the time interval which I denoted as change in T is just simply the final time subtracted by the initial time starting journey. So let's say at point A the time was 5 seconds, at point B the time was 6 seconds. Therefore, the time interval which we can denote by change in T will be 6 minus 5 seconds, and this will give us 1 second. So that being that, we define acceleration to be change in velocity over change in time, or the time interval. Now our change in velocity is going to be 10 minus 5 meters per second, and our time interval as given is 1 second. So this is going to be 5 over 1. Now let's take care of the unit. This is 5 meters per second, then divided by 1 over s. Simplifying, this is going to be 5 over 1 times meter per second multiplied by s. This taking care of the units. Oh no, sorry. Coming back here, let's redo this again. So this 5 is as a result of the simplification of 10 minus 5 meters per second. So let's express the units here. We have meter per second divided by the second here. This is going to give us 5. Taking care of the unit, meter per second. The second will come down here and multiply the second here. So this is going to be 5 meters per second square, or in index form, expressing s is going to be 5 ms minus 2. This is our acceleration. Now let's look at the acceleration. Now let's say the boy at point A has a velocity of 10 meters per second, and point B has a velocity of 5 meters per second, and time interval between this journey is 1 second. And the boy starts at point A and moves to point B, just like in the first instance, started at point A to point B. Now our V1 is 10 meters per second, V2 is 5 meters per second. Our time interval is 1 second. Now our acceleration is change in velocity divided by the time interval. So change in velocity divided by our time interval, which we represent by t. Now this is going to be V2 minus V1 divided by t. Now V2 is given by 5, V1 is given by 10 meters per second over 1 second. Now this is going to be negative 5 meters per second over 1 second. This is going to be negative 5. Simplifying the units on this side, meter per second divided by second. This is going to go to negative 5 meter per second squared. Now anytime you see a negative value, even though the unit is meter per second square, the negative indicates that it's acceleration going on there, while positive shows it's an acceleration. So that's a key take. Now for phase 2 of this tutorial, we're moving to equations of motion for a body traveling along a straight line with uniform acceleration. Now moving on to deriving the first equation of motion. Now please advise you have your pen and a notebook or a notepad beside you so you can take notes and follow along. Now just like previously illustrated, let's assume this is point A and this is point B. Now we're going to be working with letters to represent terms. Now let's assume a body is at rest or moving with an initial velocity. Now let's take that initial velocity to be denoted by u, which is in meter per second, and it accelerates at an acceleration denoted by a, which is in meter per second square. Now just like the first scenario, we had a time interval t, which is the time taken to go from A to B. Now after the end of the time interval, it will attain the final velocity, which we represent by v in meter per second also. Now acceleration is given by change in velocity over the time interval here, which we have by t. Now our change in velocity based on the terms defined here, our final velocity is v, our initial velocity is u. So our change in velocity is final velocity, which is v, minus initial velocity, which is u, divided by time interval t. Now, multiplying both sides by t, we have at is equals to v minus u. Now, we adding u to both sides of the equation. We have at plus u equals v. This will cancel out. Now, v, this is same as v equals u plus at, and this right here is our first equation of motion. Now, second equation of motion. This is how we derive the first equation. Now I'm going to derive the second equation of motion. Again, feel free to pause the video, digest all this in before moving on. Now we can derive the second equation of motion by considering average velocity. Now, from our previous video, we know average velocity equals displacement divided by the time taken. Let's denote our displacement by s and time by t. Now, what is average velocity? Average velocity is simply the sum average of the initial and final velocity. So again, our initial velocity, we take it to be u. Our final velocity, we take it to be v. Now, average velocity is the summation of this divided by 2. So putting this in letters, this equals u plus v divided by 2 equals s over t. Now let's multiply both sides of the equation by t. We have u plus v over 2 open brackets t equals, the t will distribute here and it will distribute here. When it distributes here, we're just going to have s, because to cancel this. Now rearranging, s is equals to u plus v divided by 2 parentheses t. Now from equation 1 of our equation of motion, we know that v is equals to u plus at. Now substitute this right in here. So s is going to equal to u plus v is u plus at divided by 2. Remember parentheses, then t. Now simplifying this, s is going to equal to u plus u is 2u plus at over 2 parentheses, you have t outside. S is going to equal to, this is same as 2u over 2 plus at over 2 parentheses t. S is going to equal to u plus at over 2 parentheses t. S is equal to ut plus 1 over 2 at squared. Now this is our second equation of motion. Now I made a lot of steps here. so it can be easily broken down and you understand what I'm doing. But solving consecutively by yourself, any steps you feel are not needed, you can simplify it as you so desire. Now we're moving to deriving the third equation of motion. Now, the third equation of motion can be derived from the first equation of motion. First equation of motion, our equation 1, we got it to be v equals to u plus at. Now what I'm going to do is just square both sides. So the left hand side and the right hand side of the equation, I'm going to square both sides. So v squared is going to equal to, now remember from algebra, if you have a plus b all squared, the expression is a squared plus 2ab plus b squared. Now taking u to be a and et to be b, we have u squared plus 2at plus a squared t squared. Now v squared is equals u squared plus, now a is common between these two terms. What I want to do is make this in such a way that it will be similar to equation 2. So what I'm going to do now is factor out 2a. Now factoring out 2a, meanwhile expressing this here, this is going to be 2u at, just like we have here 2ab, where our a is u and b is at. So factoring 2a from this part of the equation, we're going to have 2u at divided by 2a plus a squared t squared divided by 2a. Now nothing is changed in this equation. When we distribute 2a here, we're going to have 2u at. Also when we distribute 2a here, we're going to have a squared t squared. So we just transformed it, but it's the same equation. Moving on, v squared equals u squared plus 2a. Now let's simplify this. This will cancel this, so I left with ut plus this will cancel the squared on the a, 1 over 2 at squared. Now this is looking a lot like equation 2. That we solved earlier. Now if you recall from equation 2, s is equals to ut plus 1 over 2 at squared, and so also we have ut plus 1 over 2 at squared, which means this equals s. Therefore v squared equals u squared plus 2as, and this is our third equation of motion. Now we've come to the end of this tutorial. Now in summary, the three equations of motion. first equation of motion, we have v is equals to u plus at. The second equation of motion, s is equals to ut plus 1 over 2 at squared. Our third equation of motion is v squared is equals to u squared plus 2as. Now, terminologies. U is our initial velocity in meter per second, or ms minus 1 in index form. V is our final velocity in meter per second also, and time, and t is our time in second. S is our distance in meter. A is our uniform acceleration or deceleration in meter per second square. Now, again, remember, acceleration when it is positive, and when it's negative, that's the value, it is deceleration. So A can be acceleration or deceleration in the formula depending on the negative, whether it's negative or positive. So if it's positive, acceleration; negative, deceleration. Now, a few more tips. When a body moves or accelerates from rest, initial velocity is 0. So initial velocity, which we represent as u, is equals to 0 when body starts from rest. Now, when body comes to rest or stops, its final velocity is also 0. So final velocity, which is represented by v, is 0 when the body comes to rest. Or stops. Thirdly and lastly, if the body's velocity is constant or not changing, acceleration is 0. So A is 0 when change in velocity is 0. So if change in velocity is 0, it means velocity is constant and not changing, because remember, changes in velocity is what? Initial velocity, final minus initial velocity. So final velocity minus initial velocity. So if final velocity and initial velocity are same, there's not going to be any change in velocity. It's just going to be constant. And remember, acceleration is change in velocity over time. So if change in velocity is 0, no matter the time interval, be it 5 or 10, our acceleration is going to be 0 meter per second square. So this, we have come to the end of this video. Please like, comment. If you have any questions, drop it down in the comment section. Any videos or topics you like me to upload a video on, also drop it in the comment section, and subscribe to stay notified, and turn on the notification bell to be updated with any new uploads.